Next topic that we're going to be talking about after the free falling objects is the Hooke's law. Hooke's law basically was done by Robert Hooke, एक scientist था. उसने क्या कहा था कि जो force होती है, force is directly proportional to extension. अब ये कैसे है and how are we going to discuss this further? We'll be looking in this topic overall. इसके अंदर आपके पास कुछ strings आएंगी and we'll be talking about strings के cases. Hooke's law, the essentials. Hooke's law state क्या करता है that the extension of the spring is proportional to the applied force. मैंने यहाँ पे क्या लिखा that the force is directly proportional to extension. When you increase the force, ठीक है, extension also increases. कि कोई भी चीज, for example spring, अगर एक spring है या कोई wire है या कोई string है या कोई rope है, when you increase the force on that material, उसकी length भी increase होगी, the object would start to extend. So many other materials such as metal wire also obey Hooke's law. Now Hooke's law is associated with the initial linear straight part of the force extension graph. एक ग्राफ आपके पास आता है known as the force extension graph. ये फोर्स एक्सटेंशन ग्राफ क्या चीज है? ये फोर्स एक्सटेंशन ग्राफ हमें क्या बताता है बेसिकली कि आपके पास किस पॉइंट तक, एट व्हाट, टू व्हाट एक्सटेंट कैन यू एक्चुअली स्ट्रेच अ मटेरियल, whether it's a spring, whether it's a metal wire, but to what extent, till what point, till what limit of proportionality, till what elastic limit are you able to apply force and stretch the object? Because at one point elastic limit would be reached and the object would now break. आप एक rubber band, just imagine yourself, you're pulling a rubber band, you are actually stretching a rubber band, you are applying a force. Now that rubber band would be extending up to a point, but at one point the rubber band's elastic limit would be reached and the rubber band would be broken. वो de-elastic हो जाएगा, it would lose, हम उसको कहते हैं deformation. In physics we use that term as a deformation. आप एक रबर बैंड को स्ट्रेच कर रहे हैं, you keep stretching it, stretching it, stretching it, आप more and more force apply किए जा रहे हैं, but at one point that rubber band is going to break. That breaking point is basically known as the elastic limit. But the whole scenario जो से पीछे हो चुका है, but the point reaching till the elastic limit, उसको हम एक linear region का नाम देते हैं, where you were constantly applying the force और extension increase होती जा रही थी. You applied a force of 1 Newton, extension was 1 centimeter. 2 Newton की force apply की, extension 2 centimeter हो गई. Same the case, 3 Newton force apply की, 3 extension हो गई. But at one point, the moment you applied a force of 4 Newton, the extension went beyond और rubber band आपका break हो गया था. This point is known as the limit of proportionality. बिल्कुल इससे पहले जो आता है, and then we have the elastic limit. That every object has a certain elastic limit. Every spring, every metal wire has a certain elastic limit. सबकी अपनी अपनी elastic limit होती. Everyone have a threshold till they can be extended to a point. The initial linear part of the force extension consistent with the Hooke's law. तो कौन सा part of the graph would be actually consistent with the Hooke's law? अगर हम इस ग्राफ को दोबारा से स्टडी करें तो Hooke's law से कौन सा part agree करेगा? Only the part which is showing you a straight line. जो ये वाला part है ग्राफ का, only this is the part which is actually obeying the Hooke's law. When we talk about this part, ये जो bend होगी ये ग्राफ, this is not linear and this is not obeying the Hooke's law. ये आपका Hooke's law obey नहीं कर रहा. Only the straight line obeys the Hooke's law, because Hooke's law states that when you increase the force, extension also increases. और हमने पढ़ा था कि जो भी directly proportional relations के ग्राफ होते हैं वो क्या होते हैं? They always have a straight line. When we draw a graph of force against extension, वो कैसे बनेगा? That would always be a straight line. तो इसका मतलब ये है कि Hooke's law obey हो रहा है. But when I talk about another graph, force extension का, and I draw it a curve, अगर मैं curve बनाऊं, this is not obeying the Hooke's law. This is against the Hooke's law, because Hooke's law कहता है that force is directly proportional to extension. Elastic limit basically क्या चीज है? हम इसको स्टडी करते हैं. Elastic limit obey objects that obey Hooke's law will return to their original length after being stretched. Elastic limit क्या होती है? कि जो भी objects हैं which obey Hooke's law will return to their original length after being stretched. And if an object continues to be stretched, it can be taken past its elastic limit. At this point, the object will no longer obey Hooke's law and will not return to its original length. The spring on the right has exceeded the elastic limit. अब elastic limit क्या चीज है? हमने यहाँ पे देखा that if an object continues to be stretched, अगर आप उसके ऊपर फोर्स अप्लाई करते जाएं, if you keep increasing the force, if you keep stretching the object, it can be taken past its elastic limit. Once it is taken past its elastic limit, वो ऑब्जेक्ट आपके पास डिफॉर्म हो जाएगा, लाइक द वन शोन इन द पिक्चर, द राइट स्प्रिंग. जो आपके पास स्प्रिंग राइट पे शो हो रहा है, दैट हैज बीन कंप्लीटली डिफॉर्म. इसको हम कहते हैं दैट दिस स्प्रिंग हैज बीन डिफॉर्म्ड, इट हैज लॉस्ट इट्स इलास्टिसिटी. इसके अंदर अब इलास्टिसिटी नहीं है. This spring has no more elasticity because you have stretched it so much. आपने उसको इतने पॉइंट तक स्ट्रेच कर दिया है that it has actually lost its elasticity. Whereas the other spring जो कि आपको यहाँ पे शो हो रहा है, the left one, this one is still obeying the Hooke's law. ये अभी तक अपनी elasticity इसने lose नहीं की है. This one is obeying the Hooke's law. So the spring on the right has exceeded the elastic limit, whereas the spring on the left has not exceeded its elastic limit and can still be stretched to another point.